13 we need to solve integral 1 to 2 1 by root of 2 minus x dx. So this will be integral 1 to 2 2 minus x whole raised to minus 1 by 2 dx. So the integral is going to be 2 minus x whole raised to minus 1 by 2 plus 1 by minus 1 by 2 plus 1. And there is a minus sign over here, so that minus 1 also will come. So the integral will be from limit will be from 1 to 2. So we will get 2 minus x whole raised to 1 by 2 by minus 1 by 2. So that will be minus 2 minus x whole raised to 1 by 2. Limits is from 1 to 2. So at 2 we will be getting minus 2 into 0 minus at 1 we will be getting minus 2. 2 minus 1 is 1. So 1 raised to 1 by 2 is 1. So the value will be equal to 2. So that will be the value of the integral. And question 14, we need to evaluate integral 0 to 5 1 by cube root of 2 minus x dx. So this will be integral 0 to 5 2 minus x whole raised to minus 1 by 3 dx. So this will be 2 minus x whole raised to minus 1 by 3 plus 1 by minus 1 by 3 plus 1 into this minus 1. And we need to apply the limits from 0 to 5. So that will be 2 minus x whole raised to 2 by 3 by minus 2 by 3 from 0 to 5. So that will be minus 3 by 2 2 minus x whole raised to 2 by 3 from 0 to 5. So that will be equal to minus 3 by 2. So at 5 we will be getting 2 minus 5 is minus 3. So minus 3 whole raised to 2 by 3 minus at 0 we will be getting minus 3 by 2 into 2 raised to 2 by 3. So this will be equal to, so we have minus 1 whole power 1 by 3. So that will be, so this minus sign will go off since we have a square term. So this will be minus 3 by 2 into 3 raised to 2 by 3 minus plus 3 by 2 into 2 raised to 2 by 3. So that will be the value of the integral. So we can take 3 by 2 outside. So this will be equal to 3 by 2 into 2 raised to 3 by 2 minus 3 raised to 3 by 2. So that will be the value of the integral. And next we will look at the practice problems. In the first question is we need to evaluate integral 1 to infinity 1 by x dx. So integral of 1 by x will be log x. Applying the limit from 1 to infinity, so we will be getting log infinity minus log 1. So this will be infinity minus 0. So the value of integral will be equal to infinity. Now whenever the limit is infinite or the limit does not exist, we also say that the integral is divergent. So here it is divergent. The second problem, we need to evaluate integral 1 to infinity 1 by x square dx. So integral of 1 by x square will be minus 1 by x. So we need to apply the limit from 1 to infinity. So that will be minus 1 by infinity minus 1 by 1. Now 1 by infinity will be 0. So we will get 0 plus 1. So value will be equal to 1. And question number 3, we need to evaluate integral 2 to infinity e power minus 5x dx. So the integral is going to be e power minus 5x by minus 5 from 2 to infinity. So we will be getting e power minus infinity minus e power minus 10 by minus 5. So e power minus infinity is 0. So we will be getting 0 minus e power minus 10 by minus 5. So the integral value will be, so minus sign will cancel off. So we will get e power minus 10 by 5. That is going to be the value of the integral. Question number 4. We need to evaluate integral 0 to 1, 1 by x dx. Now integral of 1 by x will be log x. So we need to apply the limit from 0 to 1. So that will be log 1 minus log 0. Log 0. So this will be minus log 0. Log 0 is not defined. This is not defined. So therefore the integral is divergent in this case. And question number 5. We need to evaluate integral 0 to 1, 1 by x square dx. Again integral of 1 by x square will be minus 1 by x from 0 to 1. So that will be minus 1 by 1 minus 1 by 0. So that will be minus 1 plus 1 by 0 goes to infinity. So the value will be infinity. Again in this case we can say that the integral is divergent. And question number 6. We need to evaluate integral 0 to 1, 1 by cube root of x dx. So this will be integral 0 to 1 x raised to minus 1 by 3 dx. So the integral value will be x raised to minus 1 by 3 plus 1 by minus 1 by 3 plus 1 from 0 to 1. So we will get x raised to 2 by 3 by 2 by 3 from 0 to 1. So that is 1 raised to 2 by 3 minus at x equal to 0, function value will be 0 by 2 by 3. So 1 raised to 2 by 3 is 1. So upon simplifying we will get 3 by 2 as the value of the integral. Question number 7. We need to evaluate integral 5 to infinity 1 by x log x dx. So here we will use a substitution u equal to log x. So du will be 1 by x dx, and x varies from 5 to infinity. So u will be varying from log 5 to log infinity is infinity. So we will be getting integral log 5 to infinity 1 by u. 1 by x dx will be du. So integral of 1 by u will be log u from log 5 to infinity. So that will be log infinity minus log of log 5. So log infinity is infinity. So value is infinity, or we can say that the integral is divergent. Question number 8. We need to evaluate integral 0 to 1, 1 by x log x dx. So for this we will use a substitution u equal to log x. Again du will be 1 by x dx, and we will get so this will be equal to integral. For this problem, let us first evaluate integral 1 by x log x dx. So this is a substitution we have. So this becomes integral. So we will substitute u equal to log x. So we will get 1 by u. 1 by x dx will be du. So we will be getting log mod u. So this will be equal to log of, now replacing u by log x, we will get log of mod log x. So here the antiderivative is going to be equal to log of mod log x from 0 to 1. So that will be equal to log of log 1 will be 0 minus log of log 0. So we know that log 0 is not defined. So therefore this is not defined. So therefore in this case the integral will be divergent. Question number 9. We need to evaluate integral 0 to infinity x e raised to minus 2x dx. So for this we will use integration by parts. So value of integral will be first function, which is x, into integral of the second. So that will be e raised to minus 2x by minus 2 from 0 to infinity minus integral of derivative of the first. So derivative of x will be 1 into integral of the second will be e raised to minus 2x by minus 2 dx. So at infinity we have e power minus infinity here, which is 0, and when x is 0 this term will be 0 again. Then for the second integral we will get 1 by 2, 1 by 2 comes out, minus 1 by 2 comes out, so we will get plus 1 by 2, and integrating this again we will get e power minus 2x by minus 2 from 0 to infinity. So we will get minus 1 by 4 e power minus infinity minus e power minus 0. So this will be 0 minus 1. So we will be getting 1 by 4 as the value of integral. And question number 10. We need to evaluate integral 1 to 2 x square by x cube minus 8 dx. So for this we will use a substitution u equal to x cube minus 8. So du will be 3 x square dx, and as x varies from 1 to 2, u will vary from when x is 1 u will be minus 7, and when x is equal to 2 u will be 2 cube will be 8, 8 minus 8 will be 0. So this will be integral minus 7 to 0. So x square dx will be du by 3 and x cube minus 8 will be u. So we will get 1 by 3 log u from, so we can write the integral of 1 by u as log mod u, and limits are from minus 7 to 0. So this will be 1 by 3 log 0 minus log of modulus of minus 7 will be log 7, and we know that log 0 is not defined, so this will be not defined. So therefore the integral will be divergent in this case. So for evaluating this integral, so let us put x equal to root 3 u. So dx will be equal to root 3 du, and x varies from 1 to, so u will be equal to x by root 3, and as x varies from 1 to infinity, u will vary from 1 by root 3 to infinity. So this will be equal to 1 by root 3 to infinity 1. So dx will be equal to root 3 du, and this will be equal to 3u square plus 3. So we will get, so 3 can be taken outside. So we have root 3 by 3 integral 1 by root 3 to infinity 1 by u square plus 1 du. So this will be 1 by root 3, and integral of 1 by u square plus 1 will be tan inverse of u from 1 by root 3 to infinity. So that will be 1 by root 3 times tan inverse of infinity will be pi by 2 minus tan inverse of 1 by root 3. So simplifying that, we will get 1 by root 3 times 2 pi by 6, so which is pi by 3 root 3. So that will be the value of the integral.